This data set is normally distributed. So we want to determine the percent of values that fall within 1 standard deviation, 2 standard deviations, and 3 standard deviations of the mean. All right. In order to do that, we need 2 pieces of information to get started. One would be the mean, and the other would be the sample standard deviation. All right. So this is all data related to hockey teams. I probably should have put what the data refers to, but I didn't. I forget. I'll have to look it up. But anyway, at this point, we're just learning the skill anyway, or regardless. So for the mean, we're going to use the average function. All right, they don't use mean when they should use the mean, but they don't. So we're going to type in equals. It makes a suggestion. Sometimes that suggestion is exactly what you're looking for. Most of the time it's not. So average. And then highlight the data that you're looking for it to find the average of. All right, so that would be everything. So B2 to B33. All right. Some people like copying, highlighting with a mouse. I know when you're dealing with laptops and you have the trackpad, it's not as convenient. So if you do it the one time, you see that it's the interval going from B2 to B33. If you remember that, you just use that over and over again. All right. So average, parentheses B2, colon B33. You can close the parentheses or not. It's the only command there, so it'll accept it. It'll make a suggestion. Again, sometimes it's exactly what you're looking for. Most of the time it's not. So I'm going to reject this one. And we're going to go with standard deviation, sample standard deviation. So equals. If you start typing in standard deviation, you don't really get too far before what you're looking for comes up. All right, so we want the standard deviation of the sample. So STDEV point or dot S. All right. So select that one. And then we're referring to the same data, which is B2 colon B33. You could type it in or you could highlight. All right, so B2 colon B33. When you type it in, it highlights the thing that you are referencing. And you can look back and say, oh, that's exactly what I wanted. Or, oh, I think I missed something. All right, so you hit enter if you're confident. You just scroll up and take a look. Everything that should be highlighted is. So hit enter, and now you have your sample standard deviation. All right, so a whole lot easier than doing it in a calculator, or especially by hand, but definitely also in a calculator. But something to bear in mind is somebody had to put this data in here to begin with. All right, the thing that makes working with a calculator tricky is the data entry. Everything after that is pretty much automatic. All right. If you find a source, let's say you're doing a project, and you will be doing a project, you find a source and you can copy paste directly from the list into Google Sheets or Excel, then you take out an element of the data entry. All right. Pasting values from internet sources is kind of tricky, especially since each, well, it depends on the site, but in many cases, the data points are hyperlinks themselves. So you want to paste it special as values. So we'll cross that bridge down the line, though. Question, Hannah?
Could you show it from the mean and the sample deviation again?
Yeah. So for the mean, I'm hitting equals, typing average. Then I'm going to highlight the information that I wanted to find the average of. So scroll up, grab these points, and hit enter. That locks in the mean. Now, for the standard deviation.
Yeah, but when I do that and then I tap the top, everything I was doing at the bottom is gone. Like, you can only tap one thing at once.
Oh, okay, so then just, bless you, equals average, open parentheses, then type in B2, capital B2, colon, capital B33. Yeah, that's what I was saying before. Sometimes, I mean, I'm using a mouse, so it's nice and easy. But if you're doing it with a trackpad, it could be a little tricky. Right? So, typing in the row and column references might be the way to go. Right? So for Standard deviation, we type in ST. You go to pick the one that says STDEV.S. That S stands for sample. And then type in your B2 to B33. Bless you. All right. So now what I want to do is apply the empirical rule. All right. So, I mean, you can refer to the notes, but I can tell you that there's the three aspects of it. The 68% rule, the 95% rule. I should be consistent. And the 99.7% rule. All right. And you're going to have two bounds, one a lower bound and one is an upper bound. All right. In fact, you know what I'm going to do? I'm just going to copy this and give myself a little bit more room. Just shifting it down a step. All right, I'm leaving two spaces in here because I'm going to say lower bound, making a little table here, and then upper bound. All right. So I want Excel to compute the bounds, but then I also want it to figure out what goes, or how many values are in between each number. So we'll use a Countif function to do that, but more on that in a minute. All right. So the lower bound is the mean minus 1 times the standard deviation. I might be able to still bring it up here just real quick. Yeah, yesterday when we did our computations, it was a mess. I mean, you see this big old mess here. But we did x bar minus 1 times s, x bar plus 1 times s. X bar is the sample mean, s is a sample standard deviation. All right, so we're going to basically recompute or reinvent this process just in the context of Excel Google Sheets. All right, so I'm going to take first, well, I'm going to hit equals first. Then I'm going to take my mean, just clicking on that value, and I'm going to subtract from it 1 times this number. Well, you don't really need to put the 1 in there because it's just a 1. 1 times anything is anything. So I'll just say B35 minus B36. All right. Now, I want to be able to copy paste this. So you might want to put some dollar signs in there. That's my recommendation. Unless you retype everything. $ B. You don't actually need the dollar sign for the B, but, or at least for what I'm about to do with this. But you do need it for the 36. All right, because 35 and the 36. Because when I copy paste it, I want it to continuously refer to just those two numbers. If I copy paste down a cell, it changes the reference to one cell below what I have. So if I didn't put the dollar signs in here and I went down, just copied it down the line, it would change this 35 to a 36 and this 36 to a 37. Actually, let me just show you real quick. So let's say I did it without the dollar signs. So B, what was it, B35? Yeah, B35 minus B36. So I get that number, and then if I autofill, you see now it's 36, 37, 37, 38. It's not referring to the correct stuff anymore. All right, so we don't want that. What we do want is to put some dollar signs in here. If you do it for just the numbers, it'll lock in row 35, row 36. Since I'm not changing the columns, it's not going to change my B's to anything, right? If I copy down the line, all right? But if I copy over, it will change the B to a C to a D and so on. So that's my justification for putting a dollar sign on the B's also, all right? Why they chose a dollar sign, I have no idea, but it's basically their way of saying lock it in to this row, this column first, then row. Right, so you hit enter, it's in. Now, if I copy it down the line, I'm going to get the same number every time. But this one should be minus 2 times the standard deviation. So copying it is really good because then I could just make a quick adjustment. It's basically what we did in the calculator. It's just kind of different, in terms of the approach you take, but it's really the same concept. All right. So I copied it, and I just slipped in after the minus sign a 2 times. All right. And for the third one, I'm going to slip in after the minus sign a 3 times. And now I have all my lower bounds. If I copy from these values over to the upper bound, I'm going to get the same numbers, which I don't want. The only difference between the lower bound and the upper bound is the lower bound has minuses, the upper bounds have plus. All right? So just change all your minuses to pluses. All right. So now I have my intervals. Now you may look at this and say, well, that was way harder than what we did in the calculator yesterday. But just like with the graphs, we can now change the data and it'll change the values here. All right, so we could use this over and over again as long as our data has the same structure. Going from B2 to B33, for example. All right. Now, and again, I have all this pasted or saved in the solved examples. So just keep that in mind. Everything is here. You could always just kind of re-engineer what you need. Like, for example, we're about to do counts. If for whatever reason, well, not for whatever reason, but if it doesn't make sense to you, you can just go in here and have a look and see what the command was that led to that. All right. So yeah, anyway, what we want to do now is figure out how many values fall between 68. One standard deviation around the mean. It should be about 68% if it's a normal distribution. So I'm going to figure out the counts. All right. So to do that, we're going to use a Countif function. All right. But very important, and I'll just kind of jot this down on a, like a scrap notebook. Let me just bring it up on the screen here real quick. This one. All right. So that's a different class. Let's say you want to find the number of values between, I'll say 3 and 10. All right. The way you would handle that, if you're looking at a number line, I'll start with 0. 1, 2, 3, 4, 5, 6, 7, 8, and I never give myself enough room. So I want to go from here to here. The way we handle that is by figuring out all the values that are less than 10, less than or equal to 10, and then all the values that are less than or equal to 3, and then subtract the results. All right, that'll give you what's in between. All right, so if I said that there are, let's say 1,000 students at John Jay, and I want to know how many students are between sophomore or within the sophomore junior class. I could take all the students that are at John Jay and subtract all the freshmen. That'll get me everyone from sophomore up to senior. Then I could subtract off, that might not work actually. Now I would subtract off the number of juniors first. That would knock out the seniors that are in the class, and then subtract from that the number of freshmen. I mean, bottom line is you're subtracting two numbers. It's just you got to figure out what those two numbers are, which is not the easiest thing in the world, right? Analogies wise, I probably could have done better than that, but we'll see numerically what it amounts to. Let me.
By I didn't get those numbers for the upper bound.
The 111 and so on?
I got 111, but then I got 222 and 323.
Interesting. All right, so click on your cell and see what you have here, or have there. Do you have B35 plus 2 times B36?
Yes, I do.
Let me take a look. Oh, you have an extra. You don't need it for both. You just need it for the first. I'm sorry, for the second. Because it's X bar plus 3 times the standard deviation. Okay, so now I want the counts. So we'll use the Countif function. So equals Countif. All right. We're going to identify the array of data. But then I want to put the condition by which I'll do the counting. All right. So if I say that I want all the values that are less than the upper bound, I'm sorry, less than or equal to the upper bound, the way I would handle that is by putting quotes less than or equal. You just put a equal sign after the less than. All right. Close up the quotes and then identify by clicking which number you want to be less than. All right. So that would be C39. But in order, it's a weird thing. In order to reference it, you have to put an and symbol. All right. So B2 to B33, all values that are less than whatever we have stored in C39. Now, if you hit enter, that'll give me all the values that are less than or equal to the 111.283, blah, blah, blah. All right, which is going to be way more than we want. All right. So if you go into solved example, I mean, you could just look, but it's really this relationship. We're going to do the subtraction between the two countifs. All right, so we did this first part here. I just have it all pointing to different locations, but that's not really important. It's interval of values, less than or equal in quotes, and then an and symbol along with your reference point. All right, so like I said, if I leave it like this, I'm going to have way more than I want. So I'm going to subtract off another countif. This time, well, same data, really, B2 to B33. If you believe that it has accurately predicted, if it makes a suggestion, copy down the line or whatever, then by all means take their suggestion. But they're not. I mean, this is too complicated. They're not going to make a suggestion here. So we'll say B2 to B33. Oh, not 333, just 33. I want to take away all the values that are less than the lower bound. All right. So quote less than, and the lower bound is B39. All right. So really, if you look at it, the only thing that's going to change from line to line is what you're referencing in terms of the lower and upper bounds. Yeah.
In the second part, do you not need an equal sign after the less than, like in the first sign?
You don't, because if you do a less than or equal, it's also going to subtract off the endpoint, which we don't want. So hit enter. You have your value in there of 21. All right. Now, it was 27. It's now 21. We just we trimmed the 6 values that we don't want. All right. So what I want to be able to do is copy this down the line. So I don't want these numbers to change, the B2 to B33. So I'm going to put $ signs on those. in both cases. I do want the other numbers to change. All right. I want C39 to become C40, and I want B39 to become B40 when I go down to the next line. All right, because that would refer to the appropriate lower and upper bounds. All right, so now when I do a copy or drag, it'll give me the appropriate counts. All right, so this one now refers to C40 because I increased my row reference by 1. 39 becomes 40. All right, in this one, I've increased my row reference by 2, so 39 becomes 41. All right, but you'll notice that the B2 and B33 don't change because I have the dollar signs there. All right, so those are the counts. I want to figure out what percentages those amount to. All right, so in order to do that, I would like to know how many values there are in the set, but you can get that just by counting cells. I mean, one of them is a title, so you have 33 entries in total, but only starting at the second point. So there isn't really 33, there's only 32 values. So you can divide each of these by 32, but you could also have Excel count up the number of values in the set. So I'll just tuck in here, number of values. For that, we'd use just a simple count. All right, count with no conditions. There's no if. Count, then just highlight the values that you want. All right, when they say count, they're not adding. That would be a total, all right, or a sum. Here, we're just counting how many values there are. So if there's a blank cell, it would disregard that. All right, so there's 32 values here. You know what? I'm gonna tuck in a row above, just to keep it cleaner. All right, so there's 32 values. What I'll do now is create a column that says %. I'm going to take whatever I have here, divided by the total number of values in the set, get that answer, multiplied by 100. It makes a suggestion. Turns out the suggestion in this case is correct. Is it correct? No, it's not correct. So if I wanted to refer to the same values repeatedly, again, $, I want it to come back to the 35, the B35, so I'll put a $sign on that. The 100 is not going to change. That 40, I want to become a 41 and then a 42. So that's where we're at. Then we can copy that down the line. All right. If you get it, so when I hit enter previously, I got a number over 100. That stood out to me because if you have a number over 100, that wouldn't make sense. You can't have more than 100% of the values that are in the set. All right. So, folks, just bear in mind phone usage. Like I haven't really been giving people a hard time, but we're not using phones in this class. All right. Otherwise, we go to the shoe bag. All right. So anyway, we're comparing these numbers against these numbers. All right. So to determine if you're looking at a normal distribution, these numbers have to be close to each other. 68. I mean, I guess you could round it. Remember, we said 2 percentage point difference. All right. So that's fine. This one is a little far away. It's 5 percentage points off. All right, this one is close enough. So I would say that this is close to being a normal distribution, but I wouldn't claim that it is. All right, and the reason is that this is 5 percentage points away, as opposed to being only 2 percentage points away. So close to a normal distribution. All right, that was the hard one. Now, in all honesty, if you think about it, it took a lot to come up with the solution for this problem by hand. I mean, we could kind of clean up the process a little bit and make it simpler using technology, But the more complicated something is to do by hand, it kind of makes sense. The more complicated it would be to do it using technology. Right? The easier something is to do by hand, the easier technology will be to use. So that being said, the next type of problem is way easier, much, much simpler. All right, you still need the mean and the standard deviation. So what I'm going to do is I'm just going to copy this over. All right, but I'm going to change the references because it's not, well, actually it is the same number of values. It's still 32 values, but this time it's in the J column. All right, so average of J2 to J33. Standard deviation of J2 to J33. I mean, it's the same data, so the mean and standard deviation should be the same, all right? But you'll notice how I didn't have to change the B's to J's. Excel did that for me, all right? So that's what I do is I copy, paste, and then have a look and make sure it's referring to the right stuff, and if it is, we're good to go, all right? So that's there now. Now to come up with the z-score, all right, let me, you know what? These are all going to be z-scores. I was thinking about throwing a label in there. Maybe I'll just do it a column over. You know what I'll do? I'm going to unmerge and then remerge. Okay. That's good. All right, so these would be my z-scores. You don't really need the label. I just wanted to have it look kind of nice. All right, assuming you haven't copied it over yet, these changes will all be reflected on yours anyway. So z-score formula is an individual score minus the mean divided by the standard deviation. All right, so individual score minus the mean divided by the standard deviation. So equals, it's just straight computation. Individual score divided by the mean, minus the mean, then divide by the standard deviation. So I'm going to get parentheses around these two, and then divide by my standard deviation. So my first cell should be J2 minus J36 divided by J37. All right. Whenever you're writing something as a command that you want to use repeatedly, you got to think about what you want to change and what you want to remain the same. I want my J2 to become a J3, J4, all the way down to J33. I don't want my J36 to change because I always want it to point to the mean. That's where I have the mean stored, so I want it to continue to be stored there. Well, it will be continue to be stored there. I just want this computation to always point to that location. All right, J37, same deal. I want Excel to always know that that's where we're finding the mean and standard deviation. So then enter, suggested autofill. Like I said, it's not always correct, so be careful, but in this case it is correct. All right.
Minus the mean divided by?
Standard deviation, yep. So if I look at the next one, you see I'm still pointing to J36, J37, but now it's referring to J3, which is how it should be. All right. The next one is pointing to J4 and so on.
What's in J36? Is that the mean?
That's the mean, yeah. J36 is the mean, J37 is the standard deviation. All right. And that's all I need you to do for this, because we're going to learn as we go forward how you interpret the z-scores. I mean, we did a simple case yesterday, but we're going to jazz it up because, I mean, there's a lot of data here. And it's like, okay, well, what does it all mean? Anything, I'll give you the short version right now. Anything that's positive is above average. Anything that's negative is a below average value. But I didn't tell you what this data actually represents. So it could be something that you wouldn't necessarily be able to fully draw a conclusion for. All right.